Hello, ladies and gentlemen. Today we're going to look at parallelograms and tests for parallelograms. Let's start with the definition of a parallelogram. A quadrilateral with both pairs of opposite sides parallel is a parallelogram. And there's some important properties about parallelograms. In fact, they're all theorems, all right? If a quadrilateral is a parallelogram, then its opposite sides are congruent, which in this case, segment PS would be congruent to segment QR. Segment PQ would be congruent to segment SR, all right? Here's another theorem. If a quadrilateral is a parallelogram, then its opposite angles are congruent, which means angle P would be congruent to angle R, and angle S would be congruent to angle Q. Another theorem for parallelograms is if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, which means that angle S and angle P are supplementary. It also means that angle S and angle R are supplementary. It means that angle R and angle O are supplementary, and also that angle Q and angle P are supplementary, okay? The next one is if a parallelogram has one right angle, then it has four right angles. So anytime you have a parallelogram and you make one of the angles a right angle, then all the other four will also have to be right angles. All right, let's go use these theorems, starting with number one. All right, and number one, the instructions for this set of problems anyway, says find the value of each variable in the following parallelogram. So all of these four-sided figures or quadrilaterals are parallelograms. Well, if this is a parallelogram, then these consecutive angles are supplementary, all right? So 4y plus 90 has to equal 180, which means 4y has to equal 90. And if you divide each side by 4, all right, y would have to be equal to 22.5. All right, the opposite angles of this parallelogram have to be congruent, which means that 3x would have to equal 90, which means that x would have to equal 30. So there's both x and y, given that that figure is a parallelogram. Let's go to number two. All right, let's find y first. All right, that's the 8y is the length of this side. Opposite that is this 88. Those would have to be congruent because the opposite sides of a parallelogram are congruent. So 8y would have to equal 88, excuse me. If you divide each side by 8, you will find that y is 11. So there's your value for y. All right. Let's talk about these opposite angles, 6x and 90. They have to be congruent, so 6x would have to equal 90. And if we divide by 6, then x would have to equal 15. All right, so there's your value for x and y there. All right. In this parallelogram, the opposite sides would have to be congruent here. In fact, all of them are congruent, which means you get 6x has to equal 12. And also 3y has to equal 12 because all four sides of that parallelogram are congruent. Well, if you divide each side of this one by 6, you get x is equal to 2. All right, so there's x. Divide both sides of that equation by 3, you get y is equal to 4. All right, let's go to this one. All right, in this one, we could do 6x plus 12x. All right, 6x plus 12x would have to equal 180, all right, which means 18x would have to equal 180. Divide by 18, x would be 10. All right, well, let's go ahead and put in a 10 here. 6 times 10 is 60. So that would mean, or you can do 20 as 10 here. That means this would be the supplement of a 60, which is a 120, or you can put in 10 times 12 be 120. So 3y would have to equal 120. Divide by 3, all right, y would have to be 40. All right, so there's your value for x, and there's your value for y. Okay, on this next one, all right, if those are parallelograms, and I see that angle right there would have to be congruent to that one because of the two parallel lines cut by that transversal. So that would mean 2y plus 60 plus that 55 would have to add up to 180, all right? And that would mean 2y plus 115 would have to equal 180. Subtract 115 from each side would mean that 2y would have to be equal to, let's see, 115, that would be 65, all right? Divide each side by 2 would tell you that y would have to be equal to 32 and a half. All right, that's finding y. And by the way, if you go ahead and multiply that by 2, you can get this angle over here that's 2y. All right, well, or 2y is 65. So this is a 65-degree angle, and that means that one's 65 as well, which means that because the opposite angles are congruent, so 5y would have to equal 65. Divide each side by 5, you'll get x is equal to 13. Okay, let's go down here to number 6. And number 6, let's take this side and that side. They're congruent because they're opposite sides of that parallelogram, and that would mean that 30x would have to equal 150. Divide each side by 30. All right, x on the left would have to equal, those cancel, 3 goes into 15 5 times, so x would have to be equal to 5. To find y, we could go ahead and do 72 times 5. Well, that's 10 plus 350, which is 360, and that's the length of this side, 360, and that would have to equal the 2y, so 2y would equal 360. Divide each side by 2. Y would be equal to half of 360 is 180. There's your value for y. All right, let's turn the page. Okay, now there are some theorems that deal with the diagonals of a parallelogram, and the first one is that if a quadrilateral is a parallelogram, then its diagonals bisect each other, and that would mean that segment AP would be congruent to segment CP, and segment DP would be congruent to segment BP. All right, another theorem that deals with parallelograms and their diagonals is this. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles, okay? All right, so this diagonal line segment DB would make triangle DBA be congruent to triangle BDC, all right? And if you put in the diagonal line segment AC, then triangle DAC would be congruent to triangle BCA, all right? So let's go use this information and work the exercises. All right, number 1, the instructions, first of all, say find the value of each variable in the following parallelograms. Well, if those are, that quadrilateral is a parallelogram and those diagonals bisect each other, that would mean that 3x has to equal 12 and that 4y would have to equal 8. And if you divide each side by 3 here, you'll get x is 4. All right, divide each side by 4, you'll find that y is 2. All right, so there's your work for number 1. In that second one, all right, all 4 little parts would have to be congruent because those diagonals bisect each other, and if that one has 1 tick mark on it, this part of that diagonal would have 1 tick mark on it, and so would this one. And that would mean that they're all the little parts of the half of the diagonals are all congruent. So 2y would equal 28 and 4x would equal 28. Excuse me. Divide each side by 2 here would give you y is equal to 14. All right. Divide each side of this one by 4 would give you x is equal to 7. All right. Now let's look at that next one over there. And that next one, all right, if these are, it's all the sides are congruent, okay, all right, and this segment right here would be congruent to that one, and this segment right here would be congruent to that one, so all those 4 little triangles are going to end up being congruent by side, 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 okay, all right, And if that angle is 60, this one is 60, all right? And if that's 60, okay, all right, then I believe that 2x would equal to, let's see. Oh, this angle right here, if you look at that triangle right there, this angle of that triangle would have to be 60 as well, because 60 plus 60 is 120. And if you subtract that from 180, and these two angles right here would add up to 60. And I believe that they're going to be congruent, all right? And that would mean that 2x would have to equal 60, which means x would have to equal 30. All right. Oh, no. 2x would have to equal 30, which means x would be 15. Excuse me. All right. And this one over here would be congruent as well. All right. Because that means that this 4y would equal to 30 as well. So 4y would equal 30. All right. Divide by 4, y would be equal to 7.5. There we go. Okay. All right, let's go down to number 4. And number 4, we know these diagonals are going to be congruent to these parts of these diagonals are going to be congruent to each other. All right, and that would mean 10 is equal to 3x, which means x would be equal to 10/3 or 1/3. Excuse me. All right. And in that next one, excuse me, in that next one, we got a 30-degree angle there. And do we even have a y there? Oh, okay. Well, we can't find that. That's 10/3 and 10. That's 20. I think we're going to have to hold off on finding y until we learn a little bit about special right triangles. We'll come back to that one another day. Okay, let's go to number 5. All right, in number 5, that's congruent to that, and that's congruent to that because those diagonals, all right, bisect each other. All right. If that's 3x, this over here is 3x. All right. Oh, by the way, if that's 3x, this angle here is 3x. Okay. And now these are two acute angles of a right triangle. They're complementary. So 3x plus 3x would have to equal 90. That would mean 6x would have to equal 90. Divide each side by 6. X would have to be 15. All right. And now to find y. Okay. All right. I'm looking, okay, that's a right triangle. This is a right triangle. I believe that those by angle, side would be congruent. So if that's 12 over there, this is 12, okay? And this would also be 12, which means that we could do the Pythagorean theorem. 12 squared plus 12 squared would have to equal 2y squared. Well, 12 squared is 144. So 144 plus 144 would equal 2y squared, which would be 4y squared, because you got to square the 2 and the y. All right, this would be 288, so 288 would equal 4y squared. Divide each side by 4. All right, 4, 7, 72 would be equal to y squared. So y would be equal to the square root of 72. All right, and if you wanted to approximate that, you could. The square root of 72 would be about that would be about 8.49. All right. Next week, or the week after Thanksgiving, or right before Christmas, we're going to learn how to simplify that radical. Some of you may know that already. All right, let's move on to number 6. Okay, in number 6, we have this side 17, All right, and we've got a 4. By the way, that segment's congruent to that one, and this one is congruent to this one. All right, and I think, let's see, let me do this. I'm going to name a triangle, triangle ABC, so we can talk a little bit about that triangle. Opposite sides of a parallelogram are congruent, so AB is 17, AC is X, BC would be 4 plus 4 or 8, and that means that X squared plus 8 squared would equal 17 squared, which means X squared plus 64 would equal, I do believe that's 289. All right, and then if we subtract 64 from each side, we would get X squared is equal to 225. Take the square root of each side, X would be 15. So there's X right there. Okay, all right. Now, let's look at a coordinate geometry problem, okay? All right, let's start with number 7. And when you do this coordinate geometry work, I recommend that you get some graph paper. So that's what I'm going to do. Let me grab some graph paper. And a straight edge. So I'm going to grab myself a straight edge. And we'll do a couple of these. All right. Number 7 says, find the coordinates of the intersection of the diagonals of parallelogram. That's the symbol we use for parallelogram, ABCD, with the given vertices. Okay. I'm going to do number 7 on graph paper. I'll tell you right now it's not necessary. You'll see why in just a minute. But we will do it on graph paper for number 7. Maybe for number 8 we'll skip that. So there's my y-axis. All right. And here's my x-axis. All right, 3, 6. So 3, 2, 4, 6 is point A. All right, at 3, 6. Point B is at 3, 5, and then 6 plus 2 more is 8. So there's point B at 5, 8. All right. Point C is at 3, negative 2. So there's point C at 3, negative 2. And point D is at 1, negative 2, 4. At 1, negative 4 is point D. All right, I'm going to go ahead and graph that quadrilateral, that parallelogram. Okay, those two sides are parallel. They have the same slope, mainly 1. All right. These two other sides better be parallel. Okay, and I believe their slope is 4. All right. And then I'm going to put in the diagonals. All right. I'll put in the diagonals. All right. So line segment BD is a diagonal, and line segment AC is a diagonal. Okay, so there's the diagonals. And there's where they intersect right there. All right, now, for a blind man, trying to get that off the graph, that coordinate might be tough. So what I'm going to do is my midpoint formula. That's what I'm going to do. Please remember that the midpoint formula is x of 1 plus x of 1, x of 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. So if I want to get the coordinates of this point here, I'm going to do 3 plus 3, which is 6, and I'm going to divide that by 2. All right, and 6 divided by 2 is going to be 3 for the x-coordinate. The y-coordinates are 6 and negative 2, so 6 plus negative 2 divided by 2. 6 plus negative 2 is 4, all right, and 4 divided by 2 is 2. So 3, 2 should be the points of that midpoint for those two diagonals, all right? And by the way, in the other one, you can just do the work. You can just do this algebraic work right here for number 8. I'll just do that real quick. If I'm doing the diagonal line segment AC, I add those x-coordinates, negative 4 and negative 1, and divide by 2 to get my x-coordinate. All right, I have the y-coordinates, 3 plus negative 2, and divide that by 2. And this will give me my midpoint. Let's call it point P. All right, this would be negative 5/2, and that would be 1/2. All right, so there is the midpoints of that number 8, the midpoint of those two diagonals. They would intersect at the same point. Okay, all right, let's go ahead and do number 9. All right, number 9 says write a 2-column proof, because we don't do paragraph proofs, so we're going to write a 2-column proof. So I'll make my statements on the left. All right, and I'll put their corresponding reasons on the right. My first statement would be my given information, which is parallelogram A, B, C, D, and of course that's given to us. All right. And if you want, you can make a sketch. All right, that's 4 units long. Okay, I'll come down here, 1, 2, 3, 4. I'll connect. All right, so I've got A, B, C, D. All right, and what are we trying to prove? We're trying to prove that triangle AED is congruent to triangle CED. Well, there's no E in that picture, is there? Well, that basically means we need to put in the diagonals. I'm going to put those diagonals in. I'll just dot those diagonals if that's all right with you. All right, I'll dot those diagonals, and then you'll see which triangles we're talking about here. Okay, and the intersection of those diagonals is going to be point E. All right, and now I'm going to prove that the following triangles are congruent. Triangle AED, all right, AED, that triangle right there, all right, is congruent to triangle CEB. All right. Well, the first thing I would say, all right, is that segment AD, I'm going to put 3 tick marks on that segment. Segment AD is congruent to, segment BC. All right. And the reason we can make that statement is that our theorem says that if ABCD, ABCD is a parallelogram, which we were given, Parallelogram, all right, then its opposite sides are congruent. Okay, all right. Now, we also know, all right, that segment DE is congruent to segment BE. All right, so that could be my third statement. Segment DE is congruent to segment BE. And the reason would be if quadrilateral ABCD is a parallelogram, then its diagonals bisect each other, okay? So if ABCD is a parallelogram, which it is, all right, then its diagonals bisect each other. Okay, well, that also means that segment AE would be congruent to segment CE for the same reason, by the way. All right, and if I put 1 tick mark on each of those two, all right, then my next statement, statement number 4, would be that triangle AED is congruent to triangle CEB. And of course, the reason would be by the side, side, side triangle congruence postulate. I would also tell you that you could have done vertical angles and made angle AED congruent to angle BEC and used side angle side. If you had left off this the opposite sides, it would have been fine as well. All right, there's more than one way to do proofs. All right, let's turn the page over to the next page. All right, and let's talk about the test for parallelograms. All right, well, at the top, it says there are many ways to establish that a quadrilateral is a parallelogram. Okay, all right, and one way would be to know that if both pairs of opposite sides are parallel. Basically, that's the definition, okay, of a parallelogram. Another way would be to know if both pairs of opposite sides are congruent, all right? That would be the converse of that one theorem, that the opposite sides of a parallelogram are congruent. All right, and both pairs of opposite angles are congruent. That would also force your quadrilateral to be a parallelogram. Or if you knew that the diagonals bisect each other, all right, if you knew that one pair of opposite sides is congruent and parallel, then you would know that it's a parallelogram as well. Okay, all right. So let's go down and talk about the exercises down here. It says find x and y so that the quadrilateral is a parallelogram. Well, if it's going to be a parallelogram, each pair of those opposite sides are going to have to be equal. So that would mean 2y would have to equal 8, which means that y would have to equal 4. It would also mean that 2x minus 2, would have to equal 12, which means 2x would have to equal 14, which means x would have to equal 7. So there's your value for x and your value for y. All right, let's go to number 2. If this is going to be a, a parallelogram, then those opposite angles right there would have to be congruent, which means 11x would have to equal 55, which means x would have to equal 5. All right? And if we do 5 plus that right there, 5y plus 55, those consecutive angles would have to be, by the way, consecutive angles would have to be supplementary if it's going to be a parallelogram, which means 5x plus y would equal 180. And if you subtract 55 from each side, you'd get 5y on the left and 125 on the right. Okay, and then if you divide each side by 5, all right, you would get 25 for y. All right, let's move on. And number 3, if you know that if you want to force this to be a parallelogram, 5y and 25 would have to be the same value, which means y would have to be equal to 5. All right, and if that's 25 and 25 is 50. Subtract that from 360 is 310. Divide that by 2 would be 160, I do believe. All right. And that would mean 5x is equal to, 5x would have to equal let me do that again. Okay, 50 from 360 would be 310. Half of 310 would be 160. So 5y would have to equal 160. Or wait a minute, let's just do this. Those two would have to add up to 180. You can do it that way as well. Let's just do that. Plus 25 would have to equal 180. So 5x would have to equal, subtract, that would be 155. 5 goes 35 times, so x would equal to 31 times, I do believe, wouldn't it? Yeah, there we go. Okay. All right. Now, if this is a parallelogram, then that side would be opposite that, and that means this angle would have to be congruent to that angle, which means 9x would have to equal to 45, which means x would have to be 5. It would also mean that these opposite sides would have to be congruent. So 18 would have to equal 6y, which means y would have to equal 3. Okay? All right, so there's your work for number 4. All right, for number 5, you would know that 2x would have to be congruent to 30, so 2x would have to equal 30, which means x would have to be 15. Okay, all right? And if this is 24, then that angle and that angle would have to be congruent. So x plus y would have to equal 24. I've got a value of x, 15. So 15 plus y would have to equal 24. Subtract 15, y would have to be 9. So there's your values for x and for y. Okay, all right. If we talk about these two angles, they would have to be supplementary, all right? And, excuse me. So that means that, oh, wait a minute, if those are congruent, then they would have to both be supplementary, all right? Then they would have to be 90. That's the only way that would possibly work, would be for both of those to be 90. And that would mean 3x would have to equal 90. It would also mean 6y has to equal 90. So divide by 3 would tell us that x is 30. Divide by 6 would mean that y is 15. Okay? All right, so there's your value for x and for y. Turn your page. All right, on the next page, they tell us parallelograms on the coordinate plane, the distance, slope, and midpoint formulas can be used to test if a quadrilateral is a parallelogram. Okay, all right, so let's do a few of these. All right, and in number 1, all right, it wants us to use the slope formula. Okay, well, if you're going to use the slope formula, what you would need to show would be that the slopes of each of the pairs of opposite sides would be equal, okay? All right, so I'm going to grab my graph paper that I was using just a moment ago, and I'm going to come back and I'm going to do number 1, all right? So in number 1, all right, I'm gonna say, okay, well, let's sketch it real quick. I think that might be helpful. Let me or draw it. We'll graph it. So here's point A. B is at 1, 3. 1, 3. C is at 3, 4, 5, 3. C is 5, 3. And 2, 4, 0 is point D. Okay, at 4, 0, excuse me, not 0, 4. All right, so here's what that would look like if you graphed it, okay? All right, and if we're gonna show using slope, the slope of line segment AD, that's a horizontal line, and that slope is 0. Well, the slope of BC is equal to 0, equals 0. So that means that they are parallel, okay? And on line segment AB, it's 1, 2, 3 units of rise over 1. So that slope is 3 over 1, which is 3. And the slope over here is 1, 2, 3, and 3 over 1 as well, which is 3. So that slope's 3. These slopes are equal. That means those two sides are parallel as well. And therefore, all right, the ABCD is a parallelogram by the definition of a parallelogram. It has two pairs of opposite sides parallel. Okay. All right, now you could use the formula or for the rise over run. It's still slope, however you want to think about it. I'm going to leave number 2 up to you. We'll go to number 3 and talk about the distance formula. All right, in number 3, and I'll sketch that one too. I don't think that would hurt anything. All right, if we sketch number 3, all right, negative 1, 0 is point R. All right, 3, 1, 2, 3, 0 is point S. 3, 0, negative 1, 0. All right, T is at 2, negative 3. So here's point T at 2, negative 3. And U is at negative 3, negative 2, negative 1, 2, 3, down 2, right here. Okay, all right. Graph each quadrilateral. Determine whether the figure is a parallelogram. Well, I mean, you can probably see already that when you draw that segment and that one, and that one, you can see that it's not a parallelogram. But you need to show with the distance formula, okay? All right, and the distance formula, you could do one of two ways. You could show that anytime one pair of opposite sides is not congruent, that would be sufficient information using the distance formula. And what I would do is this. I'd say, okay, segment RS is 1, 2, 3, 4 units long. So RS equals 4. All right, and then I'd come over here and use my distance formula, all right, which, by the way, is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And I'm going to find the distance between point T and point U over here at -3, -2. All right, so if I wanted to find UT, hook 'em, okay? All right, the second x coordinate I wrote was -3 minus the 2 squared plus, all right, the second x coordinate was second y coordinate was -y, or -2 minus -3, that's +3 squared. So UT, we're going to hook them, all right, is -5 squared plus 1 squared. So UT would be the square root of 25 plus 1, which means UT would be the square root of 26. And you can see immediately that UT and RS are not congruent. And that's enough information for you to say that our quadrilateral RSTU is not a parallelogram. All right, I'm going to do one more. All right, and let's see. Which one do you want to do? Midpoint formula? Okay, we'll go do the midpoint formula. All right, number 6 gives you the midpoint formula, or says to use the midpoint formula. Okay, well, I'm just going to use the coordinates. All right, 3, 6. G has coordinates of 1, 2. H has coordinates of -3, 1, and Y has has coordinates of -1, 4. Okay. All right, maybe I should go ahead and graph that. It might be helpful. Okay, I'll just graph it real quick. Okay. All right, 3, 3. So 3, 3 is point F. 1, 2 is point G. -3, 1 is point H, -3, 1, and -1, 4 is point I. Okay, well, I'm pretty sure you can see immediately that if you connect those points, that you're not going to get a parallelogram. But you have to use the information that's given to you, all right? So that means I'm going to find the midpoint of segment HF and the midpoint of segment IG and show you that those are not the same point, because for those those diagonals would intersect at the midpoints. They would bisect each other, all right? So let's start with IG first. So we're going to use these two and find the midpoint. So the midpoint of segment IG, all right, take the x-coordinates, 1, and add them, or average them, same difference. Take the y-coordinates, 2 and 4, add them and divide by 2. And that would be equal to 0 divided by 2, 6 divided by 2. So that would be equal to 0, 3. So 0, 3 is the midpoint of that. 0, 3 is the midpoint. That is the midpoint of that diagonal, all right? Now let's show or find the midpoint of the other diagonal, line segment HF, okay? So if we want to find the midpoint of line segment HF, all right, we would do those coordinates, x-coordinates, 3 plus -3 divided by 2, all right? And then we would do 3 plus 1 divided by 2. When we do, we're going to get right here 0 divided by 2, and over here we're going to get 4 divided by 2. Of course, 0 divided by 2 is 0, and 4 divided by 2 is 2. And you can see that that midpoint is not the same as that midpoint, All right, there is the midpoint right there. They're not the same, so therefore, you can say that quadrilateral FGHI is not a parallelogram. Okay, all right, if you have any question about any of your work, please give me a call, show up in a Google Meet, or email me, whatever you need to do. Thank you. Have a good day.